So I'm Chase. I come from the Kubeflow project. Kubeflow, we're going to learn a lot about, so I'm not going to give you too many details, but it is basically a machine learning toolkit that is deployed on Kubernetes. So we're going to learn a lot about it. It's a CNCF incubating project. It was involved in the working group's white paper when we're talking about the future of Kubernetes. So my pitch is who would have loved to be in the room 8 years ago when Kubernetes was being pondered? Well, now you're in the room when Kubeflow's coming up. So this is the next 10 years of Kubernetes. Machine learning workflows fit really, really well on this kind of elastic distributed systems. And so this is actually one of those workloads. I've talked to a lot of customers about Kubernetes and all these different solutions, and sometimes there's not a workload. They're maybe just trying to slam a workload in Kubernetes because someone went to a conference and came back a little spicy and decided that we're transitioning to the cloud in Kubernetes. I think machine learning workflows actually work really well under the hood and can abstract away Kubernetes. Kubernetes is the engine, Kubeflow's the car, and then the model's really the driver, right? The model's the big value add. So we'll talk more about that. Can I go next? I come from TileDB. This is my day job, so I contribute to Kubeflow in my free time, and I currently work as a solutions engineer, staff solutions engineer at TileDB. So TileDB is an array-based database, or you can think of it kind of as a data intelligence platform. The idea behind TileDB is that there's this technical debt that we forgot to pay off, which is how we actually store data. So if you store data in an array, it's actually serialized on object, and that's how your computer expects to load things into memory. So you have this problem where you've got really highly dimensional data, but you have to put it on a 1D medium. And slicing and dicing that data becomes very, very expensive, and we're actually really inefficient with pulling things in and out of memory. We're paying a lot pulling things in and out of object. We were really smart, and we said, hey, object is a really easy way to just throw things, but the fact that it's in its native format versus a format that can be sliced and diced programmatically, just like we expect to bring things in and out of systems, TileDB says just do ETL once, and then you can use your highly dimensional data. So a lot of success for TileDB is in life sciences, whether it be stacks of annotated matrices for single cell or VCF data. We have a lot of claim to fame there. So definitely check it out. A really great data layer for platforms that are looking to consume data and train models. And we tie into all those lovely frameworks everyone wants to use. So that's my TileDB pitch. Awesome. Let me now find my slides. Oh man, so many slides. Oh, these are not my slides. This is like the person who doesn't search, who just hits up tab to try to run the right command. It's like awesome. So welcome to the training with me. We're gonna be talking about Kubeflow. This is me. This is my two personas. I'm either like rambling to people at conferences about Kubeflow, or I'm like hanging out with bears. So that's kind of the two sides of my life. That's actually Katmai National Park. Question.
Are those bears swimming upstream like salmon?
No, they're catching salmon, and that one's hanging out in the jacuzzi because he's had a lot of food. But this is Katmai National Park, which is actually where the grizzly guy was eaten. But it's crazy. These bears are super chill. They'll be like fishermen fishing, and a bear will like come at them, and they have to snap their line and walk away. It's awesome. But yeah, it's wild. They're like, yeah, you're gonna run into a grizzly, no problem. Just walk away. Like so, it's pretty cool. Staff solutions engineer at TileDB. If we have anyone with a background, I mean, I know job market's weird right now, but if anyone does site reliability engineering, we're actually looking for someone to work on the SaaS platform. So if that's your background, you're looking for a gig, come find me after. I love to teach. I'm a staff solutions engineer because I love people and technology and mapping people to technology to solve business problems. That's the best part of this job, is actually seeing people do cool things with tech and letting engineers bring what they built to life. So I also wrote the course, Introduction to AI ML Toolkits with Kubeflow. So it's really from zero to like just enough to be dangerous around machine learning AI. It came from my experience of understanding Kubernetes, thinking I knew a lot about Kubernetes, then hopping to a Kubernetes startup, trying to make a Kubeflow distribution, and realizing I know nothing, and then having to crash course ML AI. So this is hopefully going to expedite that process for you. That is on the Linux Foundation website. So, and it's completely free. If they charge you, something's wrong. You're on the wrong website. Pivot, panic. But I'm part of the Kubeflow community. And the Kubeflow community is pretty cool. I encourage you to join the Kubeflow community. There's a lot of really great people from all sorts of projects. This is Yuan, or he goes by Terry. He's awesome. He does stuff with Argo CD, Kserve, Kubeflow. One thing that's worth noting about Kubeflow is when you think of kind of like the OG open source, like the Mad Dog, all the cool open source, where there's a lot of different companies that are using something in production, then they're contributing to it, versus maybe one company that's just kind of contributing to this project and other people are downloading it. Kubeflow is the first version. We have a lot of different companies. It's not only just distributions, we have end users, and then we have projects that maybe need a home, right? Maybe you're the Kserve, who's phenomenal at serving models, but you say, well, we don't, what happens when we have a fine-tuned model? What happens when you have a suboptimal outcome? Well, come on, join Kubeflow. So Kubeflow became, at first, kind of a platform, and it became more of now an ecosystem. And we're adding more and more. In fact, the Spark operator just joined the ecosystem, so that's amazing. And now Feast, which is a feature store, is actually working to join the ecosystem. So if anyone has like a passion for feature stores, there's a guy named Francisco who just would love to meet you. So he's always looking for contributors. This is your invitation to join. This is one of your many like AI generated nightmares, because I went to school for game design, took one art class, and was like, glad I like programming. Artists are magicians. So computers are making my art. But join the Kubeflow community. Join our calls. We'll find ways for you to contribute, no matter what. Documentation, end user, if you're a data scientist, you want tools to be better. If you're someone who's struggling to run PyTorch, if you're someone who just loves writing Go and just can't get enough of the YAML, like we have a manifest working group, there's a spot for you, I promise. There's your website. Now, before we hop in, here's a moment of Zen. We're going to take a beat because we're about to go really fast because I got like 3 hours. So, yes. Yes. We wouldn't do that to you. We're too nice.
Oh, nice. Turning up to the ball or turning up, is that on that laptop? My OCD.
What? Oh.
Is that on that
Showing
thing?
us a pop-up that says turn up the volume over.
Where?
I don't know. Is it on this thing? I'm like so trying to fix it. I don't know. Let's get rid of this.
Oh, is he mad about my pop-up?
It's not yours. The.
It's mine.
You personalize.
I really like that pop-up. No problem. I will make it through. So if none of the demos work, we know why.
It's space on Kubeflow.
Right, exactly. You'll be the pop-up guy. Awesome. So let's talk about our goals that I may or may not achieve. We're going to do our best here. So our goals here, we're going to introduce the Kubeflow project. We're going to introduce the different components of Kubeflow. So there's a lot of different, again, we said it's an ecosystem. There's a lot of pieces of Kubeflow. First, we're going to call out some of the common pieces in any ML ops platform. You can agree with me, you can argue with me or disagree. We're going to talk about that. And then we're going to say how Kubeflow addresses these different concerns for a machine learning platform. We're going to discuss some additional integrations into Kubeflow, things that, open source has got their, you're part of the project, but you're part of the actual core repo. So there's a lot of projects that are not necessarily under the Kubeflow banner, but work really well with Kubeflow. We're going to talk about one of those. We're going to build a simple RAG application. So we've all heard about RAG. It was a fun demo. We kind of had to whip up on the fly. So we're going to take a RAG application with Kubeflow and then Kserve. First version is going to run with a CPU. It's going to be really slow. And then we're going to upgrade it under the hood, deploy a new transformer, and we're going to serve using NVIDIA NIM, a llama model quickly. And then we're going to get kind of a better response. The third version of it that we didn't have time to do is there is a fine-tuning training operator that's coming out. There's actually a really great KubeCon India demo where they fine-tune a llama using our training operator, using the Kubeflow SDK. The next version of this will then be to serve that model and fine-tune it. So that's, you're seeing parts 1 and 2. We're going to kind of slowly bring you along. Part 3 is not out yet, but we'll make a video when it is. This is the endpoint. If anyone able to log into their endpoint, you should get a namespace. It should say like setting up Kubeflow, and you should be good to go. All right. Hello, Kubeflow. So Kubeflow was born of the problem of machine learning operations. So does anyone here heard of DevOps? I know it's like only certain people heard about DevOps, no problem. So DevOps was the problem where you have developers and operations and you got to own how your code's deployed, right? You said this is a culture problem, tools, automate trust. Let's find a way to agree on things together, business objectives, and work as a team. Well, that was a little bit easier because infrastructure engineers and developers were fairly similar. They kind of spoke a similar language. But now MLOps, you threw in maybe someone who's a PhD in statistical analysis and is really built good at models, but has never thought about what does a production code look like? What does this look like when it scales? How does it fail? All these things that keep people up at night. So you had to develop this culture shift where now you maybe have a data scientist, you have an MLE, which was kind of like our DevOps engineer who spoke data scientist plus end engineer. Maybe there's a DevOps engineer in the underneath all this, and you need to have a common set of tools that still had all those enterprise non-negotiables, right? Who's accessing what data when? How does this fail in production? How do I do learning and monitoring? All these things that if you're a business owner, you really care about. That's kind of the shift to the culture of MLOps. And MLOps, very importantly, is more than just engineers and data scientists, right? As the world is now saying, I can get a return on my AI investment, we have stakeholders, we have startups spending lots and lots of money on tools. Maybe they're pulling open source models, evaluating licensing, et cetera. And now we have stakeholders who are not necessarily AI experts, but are looking to get outcomes from AI. They're hoping to automate and improve and be more frictionless to be more competitive. So MLOps is actually about all these personas and more. And this really fun question came, which is who holds the pager? So if a model goes wrong, who do we call? So this is going to be a fun poll. We're going to see this. So if something goes wrong with a model, who thinks you wake up a data scientist at 2 a.m.? In production. Inference, you're Zillow. $4 million house you just sold. It was a box. Oops. Who do you call? Do you wake up a data scientist? Yes. That's interesting. So they can't. So what does support in production mean for a data scientist? So if the model is what kind of, that's actually good. I didn't clarify the outage. It's making a poor prediction. So do you wake up the data scientist at 2 a.m.? Well, sure. My question is, how quickly can this data scientist retrain this model, get the data, root cause it? Or is it more efficient? That's interesting. You're the first person who's ever said to wake up the data scientist at 2 a.m. and I respect the boldness. That's awesome. So that's a good point. So maybe you have the velocity and the agility to do continuous training. Maybe you can wake up your data scientist and say what went wrong. My experience is that one of the culture clashes between ML ops, right, and other is, you hear like Netflix saying we're gonna do 5-minute dev cycles, but you walk to a data scientist, we're like, we're gonna do like 5-minute training cycles and pushes and releases. They'd be like, that's not how science works, right? Like we know. So the scientific method and the data and the analysis is much slower, which is good. And you're not constantly pushing out new versions of models all the time, right? Because these long training processes, which is kind of where fine tuning came from. So again, an interesting debate. Whether who you wake up, right? This is part of the culture change, right? Who owns the outcomes? And it turns out it's everyone, right? If it goes down for an API call, it's operations. If it goes down because of some scaling issue, it's a machine learning engineer. And eventually a data scientist might need to actually fix any statistical prediction problems, right? Because these are different tool sets. And because we have all these people doing all these different things within these systems, maybe deployed on an engine like Kubernetes, we saw the rise of toolkits. Does anyone have any other toolkits they know off the top of their head besides Kubeflow that's popular out there? Anyone know any? I was waiting for someone to scream SageMaker on Google Campus and see what happens. See they burst into flames. No, so Vertex, SageMaker, the Linux Foundation also has Flight, which was out of Lyft. So there's rise of these toolkits, similar to what we saw with like GitLab, right? With these DevOps platforms, and how do you contribute together within these toolkits, and how do you have them integrated, right? Even OAuth, right? How does your authentication go across your cluster? How does it scale, right? These tools, although they're maybe bound to traditional DevOps processes, there's still toolkits that can be deployed under kind of a platform. And we saw the rise of toolkits. Enter Kubeflow. Kubeflow was one of these entries in toolkits, but at first it was not open source. It was made here in Google. open source in 2017. It was recently, I mean, I say recently, but it's within a year, CNCF. Yeah, and I think someone has an opinion on Google or on Kubeflow from early. It was from second one. So from second one. So when is so there? But there's a Hello Kubeflow post. What was that?
It was in 2017, the first version, if you want to go watch the video of us releasing it, it was based on the TensorFlow CRD
Okay.
Kubernetes. And what we did at the KubeCon end of 2017 was announce that we were grouping all these things together.
Amazing.
Everything else you said is correct.
No, that's great.
Plus,
Perfect. So open source from second one, donated recently to the CNCF to be a different style of open source, kind of with that neutral party. But originally it was Google, and you had to sign all the Google and everything to contribute. Now it's under the CNCF, so kind of different rules of engagement. And from the beginning, Kubeflow's mission was composability, scalability, portability. I've seen the community sometimes says simplicity in there, but this idea of how can things scale? Can I bring these things wherever I need them to be? And then if I have tools that I have expertise in, can I connect them to Kubeflow, right? So that I can integrate things, especially early on where there was a lot more, the ecosystem was more volcanic. I think we even saw this with DevOps. I mean, the CNCF landscape, remember when Kubernetes first blew up, how do you pick those tools, right? There's so many tools out there. You had to make sure that you could bring the tools you had expertise in, right? You don't need to solve the problem a different way just because you needed a different tool. And I think this comes to the point where we got two different advantages for Kubeflow. And I think this is really critical when people think of like, why should I think about contributing to Kubeflow or using Kubeflow? So Kubeflow has a technical advantage, right? You've got a bunch of different companies with engineers saying, this is how I deploy models in production, and this is how I want to tune the system to fit my needs, right? And there's a lot of different opinions. But that also is a community advantage. Because you have these different ideas, you have different people working on things, you have the velocity, you really have that true open source where you have all these people working in parallel with different levels of expertise. Kubernetes is a big stack. Kubeflow is a bigger stack. And then we also need to work with things like Volcano, Kserve, right? PyTorch. We're going to build a training operator. We got to work with PyTorch. So the ability for this community to collaborate across communities and have someone come in off the street, any one of you can come in with an opinion on how we can do things and make your lives easier. I think that's a huge advantage to Kubeflow as we all figure out what this next generation of AI is and how it works in our environments. And the goal is to come and attack these intelligent applications from all sorts of angles. So here's this CN AI intelligence, right? This is from the Cloud Native Intelligence. There's all these different components that Kubeflow is trying to say these are great on their own, but how can we make it easier to manage these together? So what's in a toolkit? What's going to be in something like a Kubeflow? Containerization is a core part of Kubeflow that really helps with the portability of Kubeflow. You'll see this with Flight as well, right? How you can schedule tasks. This also helps with reproducibility, right? Can I ship the same amount of code anywhere and get similar responses? Workflow orchestration. Can I run batch jobs? Can I redo my training jobs? Can I collect those artifacts? Scalable and distributed processing. Do I need to go beyond a single machine, right? Especially when I cost optimize how I do things, or if I want my machine to be able to fail, if I'm doing a large scale training, if a node goes down, I don't want to have to restart that training. Integration with cloud and Kubernetes. This one's subject to opinion, but it's a CNCF project. So I could say Kubernetes is great, but I think also usage of the cloud has been important, although I know I have seen a lot of push to doing things on-prem just due to highly regulated areas, but also access to GPU resources, right? If it's on-prem, you're not sharing. And in the world today, sometimes people want to hoard their GPUs, which is great. They have the right to if they can support them on their environments. And I think this is also critical, the supporting of multiple different types of frameworks. So whether you want to use TensorFlow, whether you want to use PyTorch, whether you want to use something like the MPI operator, depending on how you want to train your models, depending on what skills you have in-house, depending on your expertise from hardware, et cetera, you want to be able to support the frameworks that your teams use, as well as the programming languages your teams use. I know I work with a lot of life science customers, and R is huge in those communities, right? And now, although Python is super highly adopted, there are a few folks that really have a lot of expertise in R. And I think we want to say, well, you have a spot at the table to use those tools if you want to. We're not trying to box you out unless there's not support, in which case you can contribute it. And then model versioning and tracking. And this is actually something that Kubeflow was not supporting initially. There was kind of a push to put ML flow into Kubeflow, but then recently we now have a model registry. So you can start to version and have that lineage with machine learning metadata using the new model registry. So you can do that versioning and you can understand the performance and the A/B and all that canary, all the stuff you want to do with different models and store them and pull them just like you would do a container. And then extensibility and customization. Again, shout out Feast. Feast is one of the newest entities in Kubeflow, or it's being proposed to be donated to Kubeflow. And that is a feature store that's going to be an open source feature store. And then monitoring and logging. We don't do currently out of the box, Kubeflow doesn't have any monitoring, like model monitoring, but you can of course do Prometheus, you could use Home GPT, you could use Kate's GPT, right, to monitor the underlying system, as well as those kind of classic golden signals. When it comes to, again, to the model monitoring, the drift detection or the context issues, we don't support that currently, but that would be something interesting to pursue. And Kubeflow's got all of this. So let's go through all of the Kubeflow components. So at a high level, this is Kubeflow. This is kind of the Kubeflow ecosystem. This probably needs to be updated. This is a really difficult chart to fully personify like which level things are at. But I like this because you have the cloud providers underneath, right? You have Kubernetes in between them. And then in between the machine learning frameworks, you have Kubeflow, right? Because PyTorch, we want to make PyTorch easy to use. If you're supporting a bunch of PyTorch clusters or TensorFlow clusters, we want to make it easy to spin those up, assign a job to them, and maybe free up those resources when you don't need them. So I really think of Kubeflow as in service of those tools above it and abstracting away everything below it. Now, currently, Kubeflow is an incubating project within the CNCF. So we have not had something called conformance. Conformance is the reason you can use like Sonobuoy for Kubernetes and make sure that all your API calls on anything that's officially conformant Kubernetes runs in the same place, right? The goal of Kubernetes is to be able to move your Kubernetes environment anywhere and you still get the API calls because it's still Kubernetes. Kubeflow, although has the concept of distributions currently, there's no conformance yet. So that's part of our goal as we start to graduate is to have the conformance and the validation, but we're still an incubating project. There is a way to install with raw manifests, and we do have vendors such as like Red Hat, Canonical, that are using Kubeflow in their stack. So we do have Kubeflow distributions. Right now, without a distribution, you have to do raw manifests. And I would argue that raw manifests, although I've seen people do it, can be kind of a pain unless you have a lot of Kubernetes expertise. Has anyone tried to deploy Kubeflow with raw manifests? Yeah, you did.
That's how I found you.
Yeah.
Yeah, once I did that, Andre said, stop.
He said stop.
And then led me to you.
Yeah, yeah. Did you get it up though with raw manifests? Wow. How long did it take you?
Couple days.
Couple days.
Yeah.
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 There's a
I had to tweak some things. So.
yeah, yeah. And I'm sure you know a lot of Kubernetes, right?
Yes.
Yeah. I think the average from some good feedback we have, and again, continue this feedback if you try to install it from even machine learning engineer teams, data science teams as well. I don't know a lot of Kubernetes. I don't know a lot of cloud engineering. So we need to make it a little bit simpler to deploy. And that's been a huge objective of Kubeflow as we continue to go forward. So this is my commitment. We're making it easier to install. We're working on it. But currently, those are your options. In fact, today I am using a distribution. Go ahead.
I just wanted to add one thing about the manifest.
Yeah.
Yeah, the manifest, it's going back to best practice, right? There's ways to install things, anything in Kubernetes, right? And, you want everything encrypted between all the all these things. But if, like you said, if you don't know all those things are even there, like how could you possibly know to tweak them, fix them? And that's what makes it very hard, especially if any of them don't work.
Right.
Yeah.
And I mean, we're still seeing this debate even with just deploying simple applications, right? We see Helm, Customize, KPT, JSONet, right? These are all these little factions here, and all sorts of new ways to try to, because templating is really hard and configuration management is hard and drift detection is hard. And you kind of have to pick your poison. And now that you're saying, well, you're essentially deploying a giant cloud platform with all these different services, that can be complicated as well. So it's something we're definitely working on. Does anyone here have a preference for deploying Kubernetes? Who's like a Helm person? What's your preference? Helm? Has to be Helm.
It's version, you gotta be.
Yeah.
Like, you should be able to delete your custom recreated thing.
Yeah. Awesome. Is anyone a big like custom? That's amazing. Maybe that's a demo for next time. Mastering Helm. Awesome. Anyone's like a big Customize or JSONet fan? No one? Yeah? All the above? You're just a master of templates? Yeah.
And Helm for third party guys.
Okay.
And then for like local stuff, like.
Yeah. Are you a crossplane fan too? Okay. Okay. I was going for like all the cool tools out there. That's awesome. Oh, phenomenal. Yeah, and that's another thing we see a demand for them like using Argo CD, right? I would love to be able to kind of do that GitOps workflow with a Kubeflow to have the drift detection. And but then again, that comes with as you were saying, a level of expertise on understanding what can be kicked, what can you just pull a manifest, what can be upgraded. You know, the versions and all the API handshakes that you have to do is complicated. You don't want to upgrade your training operator and then break your pipelines. And understanding that ecosystem and what it really means and how these things integrate together. And if it's truly microservices where things can just kind of upgrade and not care, or if there's some N-2, et cetera, considerations. So if you want to go check out the Kubeflow distributions, there are Kubeflow distributions. There are limited versions of support. As we were donated to CNCF, I think there's been kind of a holding pattern as we figure out what conformance is on contributions. I think a lot of these distros would be happy that you're saying I'm interested in their contribution, but they're just trying to figure out kind of what the next era of Kubeflow brings. Today, I'm bringing to you the GCP distro. I really like the Google distro. I'm very comfortable with Google Cloud. There's nothing wrong with any other distros. I'm a huge fan. It's got a lot of great features, adding you all to the identity-aware proxy. We need a SQL instance. You can pull up a cloud SQL instance. The cloud storage is phenomenal. I think there's a lot of really great features. My only concern, or not concern, but warning, if you want to use it, absolutely go ahead and use it. Just know that it's at 1.8 right now, and 1.10 is coming out. So if you go online and try out some of the examples they're like the fine-tuning operator, I haven't validated them on 1.8, and I'm not sure if they'll work, but it's still like a pretty great way to stand up Kubeflow, in my opinion. So I think a lot of these distros are phenomenal. A few limitations just for today. I would have loved to do kind of like a bigger training. I hit some GPU quota issues because we were just doing this on the fly. So we're just gonna do, that's why we're kind of doing the simple RAG application where we're just gonna serve like Llama. We're gonna show you how to use Kserve. As well as we're using an older version of Kserve. So some of the fine tuning and serving, like there's VLLM now for Kserve. So it's like really much easier to serve a Hugging Face model. So when we start to look at the next version of serving Llama and then retraining it based on the responses, that'll be much nicer with the new Kserve interface. As well as there's an older version of MinIO, depending on your environments. MinIO had changed their license. So Kubeflow still uses MinIO to abstract some of the object APIs, but due to the change to AGPL, Kubeflow wasn't able to upgrade their MinIO, so they're still using an older version of MinIO, which is actually a Google Summer of Code task, is to potentially explore other options. Another big part, so let's kind of dive into all the different components for Kubeflow. So Kubeflow notebooks, definitely one of the most popular parts of Kubeflow. Kubeflow notebooks, I think of these as like labs as a service. They're basically Jupyter notebooks. They can be R notebooks, they can be whatever you want. but they tie into Kubeflow. You can do things like give them their own authentication token for Kubeflow pipelines. You can do things like, you can security scan the container. You can then present to your data science teams containers. You can then version those environments. So you build a model on one container, and then you serve that notebook, that exact image, into maybe a namespace where multiple users are in there. They have that exact versioned pinned containers where they can hopefully launch an idempotent workflow, get the same outcome, et cetera, within your Kubeflow environment, as well as they know that the packages on that container are hardened and ready to go. What you'll see with Kubeflow as we continue is it really wants to bring you along. We don't want to say every time you launch anything, you have to build a giant pipeline and build a container. We know that's not how people work. We know, you want to make sure that previous development patterns are not retired. We want to evolve people to the new way. So we'll see that there are ways to build components just using kind of pip install on the fly. But when you say, well, this is now moving closer to production, you can start to harden, and you can start to say, well, let's build a container, let's version things, let's make things more repeatable. You can also, so as I said, you can present a custom notebook to your team. If you want to build a notebook and put your in-house packages, you can do that. There's a tutorial there on how to do it. Feel free to reach out if you struggle with it. You know where to find me on the CNCF Slack. But if you have in-house packages, as long as you follow our way to build a notebook, you can actually provide that. And we'll show you after this. I'll take a sec and we'll show you how to do this. You can actually then select that image, or you can either from either a dropdown, or you can enter the image yourself. And then your users can bring up whatever packages they need. Notebooks v2 is also coming. So Notebooks v2, again, Jupyter Notebooks or whatever you want, v2, the new experience is coming out. If anyone is a front-end developer and really wants to contribute to Notebooks, I think we're looking for some more contributions. But Notebooks is very, very popular because it provides that portal into Kubeflow. It's a lot of people's first stop into Kubeflow. So let's actually quickly, for those who have a cluster up, can everyone see their cluster? Can anyone log into their cluster? You can? Okay, perfect. Everyone should be. So from here, if you wanted to create a notebook, this is the Kubeflow Central Dashboard. Again, if you use, I think it changed a little bit in 1.9, but this is the Kubeflow Central Dashboard. If you wanted to create a notebook, you just hit the Notebooks tab. And from here, you can hit a new notebook. You can decide what type of notebook you want. We can name this notebook my new notebook. You can request as many CPUs as you want. What's great about this is that because this is Kubernetes and because this is under the hood of a cloud platform, you can restrict what people are allowed to access, right? You could put like OPA, Open Policy Agent, saying no, you're not allowed to request 300 CPUs. You can also set limits at the cloud level, saying no, your team's only allowed to have X amount of CPUs, or the namespace level, where you can say you personally can only request a certain amount of CPUs. And then what happens is Kubernetes will schedule this for you and actually scale up your nodes. You can do this with GPUs, where you can select a specific vendor. You can actually even expand your volumes and choose what storage classes. All of this self-service without having to contact IT, which is the goal here, right? You set those barriers, those boundaries, and then you launch. Once you hit new notebook, which everyone can do right now, I think the cluster is big enough to schedule. It should take a sec, and you should see your notebook. Oh, did it just melt on me? Yeah, you should see your new notebook come up. If you click on your notebook, you can actually get all the details of your notebook without even running these kubectl commands. If you're a Kubestronaut, you can go find all this yourself. Are you a Kubestronaut? Wow, congratulations. That's awesome. So if you're a Kubestronaut, you can see all these commands yourself. But this just gives you a view of the logs and the events, and if you really care, the YAML that actually created this notebook. For those who are like Kubernetes geeks, this is a notebook custom resource definition. So you can actually, from your Jupyter Notebook terminal, you could do like a kubectl git notebooks. And I can see my notebooks that are applied deployed as a custom resource definition. So I'm actually speaking Kubernetes to deploy the Jupyter web application, exposing it for everyone, and enabling them to run it. Another cool thing about how Kubeflow does notebooks is you can actually provide with Kubeflow configuration options. They're called a pod default. They're actually a mutating webhook. And what you can do is you can have advanced options, such as mounting a secret to give someone access to Kubeflow pipelines. So maybe you have a data store where you want to say, hey, let's give someone in this namespace access using GetOps to, Snowflake, whatever your storage layer is, right? S3. You can use this to create a configuration so your teams or your users can actually see this and click on it. You can set affinities, etc. And then you can launch your notebook. There's also, this is where you would change images if you wanted. You can update your images using a custom notebook. You can see all these images. You can provide these for your users, and they can select these images based on what's validated within your environments. And then you can enable or disable the ability to pull external images. And that was a notebook. Was everyone able to spin up a notebook? Well, ooh, I wonder if the cluster is not scaling up. Oh, I did auto scaling and set it to 10. It must not have listened to me. All right, we'll fix that. Did I fix that now? We'll keep chugging and we'll fix it. The next part of Kubeflow that we want to discuss is the unified training operator. Who has heard of the training operator from Kubeflow? No one. The Kubeflow training operator is pretty popular. It's similar to what you just saw. So what you just saw, who here knows what a custom resource definition is? A few folks. Okay. So a custom resource definition is a way to take something like an application and make it in Kubernetes language. So Kubernetes can create volumes, it can deploy pod or containers, it can mount images, all these things, right? And you want to define that, well, you can create a custom resource with an operator or a controller. And so instead of saying, I want a volume, an image, exposed, mounted, you just say, I want a notebook, right? And it creates a notebook. Well, the Kubeflow training operator takes that operator pattern, but for PyTorch jobs or TensorFlow jobs, or I think there's MX, MPI. There's a bunch more that are actually being supported more and more. I believe Spark jobs soon. And the idea that since it's a single operator, just like a normal human operator, the whole idea behind a Kubernetes operator is to automate the operations. So it will create the cluster, it'll schedule the code to a PyTorch cluster, it'll train the model on the PyTorch cluster, and then it will actually free up those pods, which if you have auto scaling set up, should actually scale your cluster down. Or up, depending on if you want. And you can also do things like, hey, I want GPUs for this part of the training, et cetera. So it allows you to be really self-service. And again, even at the namespace level, you can restrict what people have access to, what teams have access to. So you can say you're not allowed to request 300 GPUs. So you can then make kind of these scaling decisions, business decisions. How much of the cloud resources do you want to allocate to certain teams? And maybe certain namespaces are allowed to scale larger. The training operator will simplify all those operations for you, so you don't have to actually support the life cycles of those clusters themselves, the PyTorch clusters. And it looks like this. Does anyone use Volcano or Q in their environments? No. Does anyone know what Volcano or Q are? Awesome. This is a good time to talk about them. Volcano is it's a batch scheduling tool. It's another CNCF project, and it's the issue of, hey, you've got 1,000 pods, maybe they need to all schedule at once. But there's this weird thing, there's all sorts of weird things that need to happen as in topology-aware scheduling. How can you schedule things as close to each other as possible? How can you make sure they have the appropriate drivers? How can you make sure that your cluster is not gridlock? So you want to do maybe gang scheduling or batch scheduling. Volcano will help with all those problems and more. It has some algorithms around it. Volcano is a custom scheduler. Now, Q is a different tool. Q is using the Kubernetes scheduler, but it's more intelligent about when it's scheduling things on your cluster. And that was a big thing in KubeCon North America. There's a lot of Q topics. So Q is definitely an interesting project to look into. But it's this concept of you've had all these resources. How do you efficiently schedule them across your cluster so they're not competing for each other? Q and Volcano are great resources for that. And if you're looking for a great talk on end-to-end LLML ops on Kubeflow, this is a talk from KubeCon India that the community did, and they trained a llama model using the new train operator. So they're trying to simplify where you just, in fact, the Kubeflow operator might be called the Kubeflow trainer. We're working on it in V2. But the concept of, can I just do like a kubeflow.train, point to a Hugging Face location, pull the model, tune the model, and then push it to our new model registry, and then you have a fine-tuned version of the model. Can we really simplify that process, similar to what you've seen with tools like LangChain, right? Where there's a lot of maybe simplicity in LangChain. Maybe you just want to use PyTorch directly. Or trying to say, listen, there's a lot of orchestrating of the infrastructure. Can we improve that process and kind of unify the pipeline plus the training plus kind of just the SDK experience? Can you just scale from your notebook in an API call that calls the distributed operating system, that's Kubernetes, versus training something in a giant notebook or having someone write really hard to maintain gross pipelines and then push those out, which is comments.
Besides PyTorch or TensorFlow, can you deploy like the other runtime, like Llama CPP?
What was the question? Llama CPP? Mm-hmm. That's a good question. So I don't know as much about the Kserve project because it's a little bit adjacent. I know you can use the Open API interface to deploy it as well as the VLLM currently. So, but that is a good question, and I'll take note. I'm going to go ask the Kserve people if there's a better way to do it. But I know those are the ways I've messed around with deploying it, so I don't know. That project also moves really fast, so there's a chance that someone just heard that through the force and is now integrating it. So. Next, we have Kubeflow pipelines. So actually, before we do that, let me just go take a look for fun at what that would look like. So let's go to this is from the course. If you take the course, you can just pull these examples down. But if we have a training operator and I want to make an XGBoost job, this is how I would schedule that XGBoost job. So at a high level, it's a bunch of YAML, it's a bunch of manifests. But in theory, you could submit this and it would pull the code, create the XGBoost job, create the cluster, create the replicas of workers, et cetera, clean it up and go. And then if you wanted to monitor it or get the status of that job, you could actually do kubectl get XGBoost job. Yeah, it is small. That's why everyone was squinting. It's like, I was like, did I do something wrong? What's going on here? All right. Is that better? Yeah. So I assume no one here wants to just read YAML, but I might have assumed wrong. So here's YAML. But when you think of the complexity of maybe like deploying your own XGBoost job, the ability to package your code and set it as a manifest that you can deploy and have the same job over and over, especially if you can, I mean, you have to be able to pull the same data, right? That's always the issue with reproducibility. But being able to do this, you can then use this spec to deploy it. Again, we're trying to make this even easier, but making this an SDK call. Think of YAML. This is just a bunch of API calls to Kubernetes, right? And they tried to make it configuration as data versus configuration as code. This is kind of, it's a little bit easier to manage. It's just a nested API v3 spec. We're trying to make this even easier. We want to just say, why can't this just be like a Python call where you say XGBoost job, and then you just pass into your whatever function all these things that you need and it goes, right? Just a different way to do it. I think it's just kind of the next level of maturity, but this is kind of the root of what XGBoost or what the Kubeflow training operator does. And by the way, it's still pretty great compared to what it used to be. And you don't have to support a bunch of random PyTorch VMs out there. All right, moving on. Oops. Does anyone have any questions so far about anything? I know we're going a million miles.
Chatter these days about Triton.
Yeah. Yeah. Yeah, so you can actually use Triton with Kserve today. if you wanted to serve a model using Triton. Absolutely. Do you use Triton in your environments currently?
People experiment with it.
Yeah, yeah. That's definitely something that supports. I've also I've had a lot of success with like NVIDIA, like their NIM. You can pull their containers. We'll do that today. We just pull a container and serve it with Kserve. So I think that we're seeing these ecosystems mature, and there's a lot of great ways. There's like more options, I think, than ever to do things like serve. The nice thing about Kserve is attempting to be more serverless. So it's really you're pulling that container, you're serving the model. And if you want to deploy the next version of it, it will scale down the other model and bring in the new version using, I think you don't have to use Knative, but you could. So then you can route the traffic to that new model. And you could, if that new model underperforms, you could be like, oops, and revert back to the previous model because you have that declarative language. So you can pick and choose your models, as well as because these are microservices, then your model can also scale up. You can like scale up your model based on demand, similar to any other front-end application.
Kserve, I guess, serve a model from Kserve, or like a wrapper to another server?
Yeah. So you can serve a model directly using Kserve. Yeah, and it's Kserve is designed to try to be, when you deploy a container on, say, like Docker or Containerd, you don't really care what language it's written in, right? I just need a RESTful API endpoint. That's kind of what Kserve is doing, because back in the day, which by the way is not that long ago, if you wanted to serve a model, you maybe had to wrap it in a Flask application. You had to give it some sort of API. And also you had to make sure that the underlying server matched the framework it was trained on. Well, Kserve says, well, there's all these different frameworks that now can serve different, these serving frameworks that can serve different model frameworks. Or can we be intelligent enough that you just say, hey, Kserve, serve a PyTorch model, and it's smart enough to grab the PyTorch server or whatever you've allocated as that server endpoint. And then for every version of that PyTorch that you want to serve, you just pull that one model and it gives you that API in front of it. So.
Using the Argo, which we use the Argo CD pipeline to deploy or monitor.
Oh, of the Kserve model? So you could push, yeah, you could, it's just a custom resource definition. So you could push it to Argo CD. Also under the hood for Kubeflow pipelines is Argo workflows. So Kubeflow pipelines is a wrapper for Argo workflows, but I believe you can also use, I think Tekton now we support as well. So I'll have to, don't quote me on that, but I think we do. Which brings us to Kubeflow pipelines. So Kubeflow pipelines, they're pipelines, right? Like other batch scheduling tools. Has anyone here used just like pure Argo workflows? You? Wow. You've written like handwritten Argo workflows? Oh, yeah, just use template. Argo workflows are great. They're very customizable. They can be really complex. I think this was the idea, is how we, again, simplify the abstraction stack and make it easier for data scientists to use. So that's Kubeflow pipelines. There's different ways to build pipelines. I think we kind of alluded to this. We'll talk about those in a sec, but the idea is you can go from like a simple pipeline that you just kick off from your notebook, or maybe you're pulling packages on the fly. You can do from a more hardened pipeline in Python. We make it really easy to build a component in Python, or you can make an arbitrary code pipeline component. Again, like it's a container. I don't care what the code is, as long as you give me an API and as long as you give me a way to pass the data. That's kind of the goal of Kubeflow components, as well as a way to make them shareable, right? You can like share Kubeflow components with people. You can say, hey, here's my Snowflake attacher, etc. So the three types of components we have are the lightweight Python components, the containerized Python components, and then the container components. Again, lightweight is just pull your components on the fly. You can go right from notebook to container component. Python component, you actually build a container and you harden it and you pass it to the pipeline. And then containerized component, you actually have to kind of build yourself. The Kubeflow SDK won't help you as much. And then Katib. Does anyone here know what Katib is? Or does anyone here do anything with hyperparameter tuning? You do hyperparameter tuning? What do you use for hyperparameter tuning today?
I've been using a lot of weight biases, but I'm more interested in something else.
Okay.
I really do not like the.
Okay. Okay. Does anyone know? I mean, I'm sure you do. Does anyone know why you hyperparameter tune a model? What's the difference between training and hyperparameter tuning? Right. These are right. These are configurations outside of the model training that you can change to impact the performance of the model.
It's very high variable, sensitive, and they have some bias. You have one set of parameters, and the other example is that the output, the accuracy recall, depending on your requirement, you can, for example, train the learning rate or some other parameter.
Right. That's awesome. And so this is again data scientist, right? Yeah. So my job as a machine learning engineer or MLOps engineer is to provide the framework to do things like that. But the problem of when you're trying to find maybe the minimum for algorithm for your problem, but if it's non-convex, you don't know how far you're going down the gradient descent. You don't know where the actual bottom is, right? You're like going through this valley in the dark, and you're like, do I take 13 more steps when I'm paying for each one of those steps? Or am I just going to start going back uphill? And then, it's similar to grid search problems or map search problems, right? It costs money to search. It's expensive to search. So do you keep searching, or do you say, I've reached a minima? And that requires a lot of experimentation. That requires actually, just like any other scientific method where you have a hypothesis and you've got a system to try to find that. Hyperparameter search is a way to attempt to do that with Kubeflow. So you provide it with, and we'll kick one off here, where you can try to solve for the minimum of a function or whatever you're trying to solve with your function. And you can set up a certain amount of experiments, and how many do you want to run in parallel? How many do you want to run total to try to find the best possible value for your algorithm? And that's with Katib that runs on Kubeflow. So we'll show you Katib. Katib is part of Kubeflow, and you can define, how I showed you, you can define like an XGBoost job. You can define a Katib job as well and say, Katib, go out there and try to find the hyperparameters for this model for me. And you can set up the experiments because, like I was saying, you got to search, you got to keep trying to find where the actual minima is. It'll go out there and run a bunch of tasks, experiments with different values to try to find the optimal value. And there's also, I believe in alpha, like neural architecture search as well. So like, how can you be more intuitive with designing your actual neural networks, which I think is a little beyond me. It's pretty cool though, but something that auto ML is on the rise. Is anyone here exploring auto ML? No? Okay.
Is that a reference to a product or a concept?
Concept. Auto ML is the concept of, can you replace your data scientists with basically throwing large amounts of compute? Not, with Katib, can you throw a lot of experiments out there and make them smarter at maybe finding through experimentation the optimal neural network versus having maybe a data scientist with intuition find it? Is it better just to kind of brute force it? Almost like the hypothesis of big data, right? Can we just take as much data as possible to train the model? Or is there a distribution of that data that's actually valuable? If you're learning Chinese, do you read every book in the library, or are there 6 that, well, you got to find those 6 books, and that's expensive. So maybe it's actually easier to just try to train on everything or hyperparameter tune. So auto ML is something that I don't know the full history, but something that's being explored, especially on hyperparameter tuning and neural architecture searches.
I have a question. Is it not used by any of the scientists that AI?
Is what? I am not sure. I have not heard of that. Have you heard of that? The question was Katib used by anyone in OpenAI? Has it been used? And I said, not that I've heard of, but I can definitely search. I can definitely ask the community. Yeah. I know that they use a lot of Ray, OpenAI. And I know that the CubeRay project is very proud of that. So I think there is a lot of use of Ray, but I have not heard of them using Katib.
My follow-up question to that is, for HR and cooperation, is Katib a similar platform where you can integrate it with like a user platform like Okta, where you can back on employee engagement or get guidance on like user opportunities.
So the question was, can you use Katib for like HR and business optimizations, right? Was it feedback from employees? Is your question, can you set up an experiment to try to tune things using Katib, or can you just plug Katib into Okta?
I think. What you might mention that is also like the data. You know, it's not.
Yeah, off the top of my head, this is a potentially really cool use case. I have not seen this use case out in the community, but if is there a way with data scientists or engaging with these data or Okta we could do it? It'd be really interesting to explore, but I just haven't heard off the top of my head anyone doing it. But good question. Any other questions? Mm-hmm.
The expertise, the domain knowledge. For example, the information knowledge accumulated from the web lab or the years of expert information. Is there any way to inject that information like control credit or reward system built as part of the workflow, like a fine-tuning reward? So other than the AUC or the loss function, you add another customized domain customized reward into the workflow. Is this something really effective?
So the question was, can you inject kind of a reward system into the workflow? So there's brute force, which might be eventually the best option, but it's very expensive, right? It's very expensive to test every single possibility. And there's certain, even crypto problems where like you'd run out of time on Earth, right? To try to like hack encryption. So is there a way to then create a reward system with Katib to make it more intelligent? And based off my understanding, and I'm not a Katib super user at all, my understanding for Katib is there are different types of algorithms that you can inject those weights into, but whether you can develop a specific beyond, I know there's like evolutionary algorithms you can attempt beyond those like algorithms and frameworks we provide. I don't know if there's a specific way that we have to easily just inject a reward system to the model, but that does not mean it's not possible. It just means it's beyond my scope of Katib expertise, but I'm absolutely can take that question up with the community and see if there's a good way to do it. Yeah. Awesome. Let's go ahead and just for fun, kick off a Katib job. So let me go to here. I think it's actually going to get mad at me if I have a Katib job already. I can sense its anger. Okay. Uh, oh, actually, I can just pop my notebook. So here's a notebook we can use to kick off a Katib job. You just import Kubeflow Katib. Yeah, as long as you're running on, yeah, if you're running on Kubeflow and you can authenticate to Kubeflow, it'll kick it off. Same with Kubeflow pipelines. And in fact, with the part of the training operator V2, which is actually an open issue. So if you want to give feedback or try it out, is well, how can you even improve that experience more? A couple years ago, there's a similar project called Kale, and Kale was an ability to take Python cells, and then you could click on the cells and you could say, actually make these a pipeline and run with these images. So a data scientist could literally, because when you think about like a Jupyter notebook, right, you run it in a specific order. Well, with Kale, you could then run it in a specific order, but then you can also add some more kind of logic to it. But it was just a way for a data scientist to compile a notebook and they would launch a pipeline for them. Although the namespace itself or the notebook itself might not have a ton of resources, you could then burst out, run the pipeline, and then get the response back in your notebook. Now, what's the next version of that? Do we bring back Kale or do you make an SDK? Is it one or the other? I think that's the goal here, to make this easy to use, as well as then what does that look like in production? Because production has some realities of having to build packages, et cetera, right? And pin dependencies. So So once you kick off a Kubeflow pipeline or a KTIB, that's a great question. This is just a silly, it's like the Ackley function, which you look at it, it's like if you look at like trying to find an Ackley function, it's like a tornado, it's like Twister. It's got like a really, really deep minima. So it's just a fun kind of toy example of how you can set up an experiment and run it. And then once you kick that off, you can go to experiments AutoML. And it should start running my experiment. I think what's happening here is I can't scale up my cluster, would be my guess. Oh, it's running. Or they're pending. Give me a sec here. Let me stop. There we go. There's some good questions today. I like it. So you can, the question is, can you use Kubeflow to maybe do a migration? And so with Kubeflow pipelines, you can execute arbitrary code and you have access to, say, object. So you could build components that do those kind of workflows. That's the power of components. It's also the power and weakness is that you can kick off arbitrary tasks with them. So if you can write the script, they'll launch. The question is, is it more efficient? How do you handle the data processing platform? Is it more efficient to use vanilla pipelines or use something like Spark or Ray? That's kind of the question you can have. But again, if you're using Kubeflow, you also then have access to the Spark operator and then the Ray operator to launch off those workflows as well.
When you save it, right? So you save all the data, so the container will contain everything. So that someone can duplicate or you can control what's going to.
That's a great question. So when this is kind of the question of reproducibility and replicability, and it's difficult, right? So do you bake in all of your model's code into the container? Now, most customers or most users that I see don't, because a lot of these data sets can be super, super, super big. But what they'll try to do is they'll use a tool like MLflow or MLMD to have the artifact lineage of the data that's going into training the model. And hopefully they have that version data set. There's a really interesting, there's actually an NVIDIA talk for one of their conferences on determinism that actually talks about how models train, it can be really hard to get them to be two models like perfectly acting the same. So it's an interesting use case, right? Even the memory. I mean, part of I believe Volcano, you can choose what memory architecture to deploy to and what CPUs, because those can affect, if you got different CPUs on different nodes, things can change. So yeah, I mean, a way to think of a component definitely is like a cloud function, right? So like a Kubeflow component or this or KTIB. Yeah, yeah.
Going to feed it a bunch of random variables, finding results, and then create a model.
Right, that's what you could do with KTIB. Right, that's the AutoML. Yep, and it'll actually show you the different parameters for the runs, the trials, the details, and you can configure your goals. Right, it doesn't always have to just be accuracy. You can set those with KTIB.
And more common use case inputs and outputs are unaware of the function.
Right. KTIB? Yeah. Yes. So you could use, does KTIB out of the box? This is beyond, I don't know if you can just automatically deploy out of the box with KTIB, but you could use KTIB to say, here's the best parameters for the model and then deploy that model. Right. Or even just the model. So once you have the model, if you have the model, which is, just serialized data, you can then push the model to the registry. And then whenever you want to serve that model, that model itself is version. You can pull that version of the model, which could be the best to run into your environment. Again, kind of the AutoML. Let's kick off 14 million trainings and see which one pops out. All right. So that was KTIB. So once our cluster, hey, were people's notebooks now able to schedule that we're trying to schedule notebooks? Perfect. Our cluster scaled up. I ran out of quota, of course. I tried to make the node pool too big. So that was Katib. Now, out of the box, this distribution comes with a few pipelines. We can just show you how they kind of work. When you create a pipeline, you hit this, you can create a run. Sure. You could do you could do that with a pipeline. You could do a training workflow with a pipeline. You could do a data preparation with the pipeline. Yeah. Right, that could be the first step. Right, yeah. That's commonly, when you see a lot of the examples too, it'll be, pull data, maybe clean data, normalize the data, all those functions. Again, because it's arbitrary, these are cloud functions, input, output, you create. But then you can also, because of how we define the SDK, or the code itself, you can choose which order things run and what's dependent on the previous step. And then it'll actually pass that data along. And so this quick kind of example that we show that comes with this distribution shows how you could set up a DAG, which is this is a DAG, right? Workflow. What was it? Dynamic acyclic graph? Directed acyclic graph. So it goes one way. When you kick this off, you can see that you can have a pre-process step, pass the data along and keep moving. It uses currently, I believe it uses object for the marshaling. So these are ephemeral jobs. It'll spin up a job, get work done, and then pass that work on, and then pass the details to the next. There's different ways you can pass, but that's like Kubeflow advanced class. We're going to save your brains. But you can pass. Just know that you can set up pipelines and pass data along. No, this is a great question. This is why I'm here. So let's actually look at them. So if you want to look at different components. Right. So if you have a component, you want to define a component. This is what you would do to define, let's say, just a simple Python component. You just define the function for a lightweight Python component. It has to be a self-contained function, and then you would call the KFP client, and then you'd run the client and pass in the arguments. So think of the pipeline as the full function, right? It's a full batch job, and then each of the steps would be the components. And then you actually submit to your pipeline, the entrance values, and then the output at the end as well, the pipeline client.
The data collection, the model training, the evaluation, like that. So
right.
We define one pipeline and then we add components that does individual job.
Right, right. And there's 3 different ways to build the components currently. This is the simple way, where if you're just experimenting, if I just kind of run through this, it'll kick off a really basic job. Beyond this, you could do a containerized Python component. And this component, wow, I'm mad about an output previously. This component, you would then define an image, right? And then it will just input, it will set up how you pass to the container, the arguments to the container, and then it will pass out the output.
One component, another component,
yes. So if you look at this, so let's just say this example, we define a containerized Python component, a lightweight Python component, and then this is a containerized, not Python containerized, an R component. Then you declare your pipeline here. Task 1 equals this function, task 2 equals this function, task 3 equals this function. And notice that we pass the previous tasks that they're dependent on. And so when you kick this off, it'll return whatever the third task's output is. And again, you submit whatever you want just to the pipeline. The pipeline will then pass that data and the work from each step, right? It's almost like you light the match and let things go, the top of the first domino. And then at the very end, you'll get the output from the actual pipeline client. The question was, does Kubeflow provide an SDK to work with these pipelines and tasks? And it does. It provides, especially for Python components, It provides a way to do lightweight components as well as how to build an actual containerized Python component. So instead of having to deal with all the Docker build, et cetera, you actually can use our SDK and it will give you all of that and then build and push your container. And then you just call that container from the SDK and it'll run on Kubeflow. Yeah. Happy to point you to some examples as well. Yeah. If you pull that repo that I gave you as well, there's some Hello World examples, and I think we have some through the community. Yeah, happy to share some, and we can discuss what it takes to build components. So, great question. So we've talked about Kserve a lot. Kserve. Kserve sits with, I believe, Knative is no longer a hard dependency. I just pulled from this website. It gives you a serverless way to deploy your models, right? That's framework agnostic. You declare the framework. It does the API at the Kubernetes level. It'll serve your model for you from model storage. That could be, I said there's support for Hugging Face. There's also support for the model registry or simply S3 if you're just going to pickle a model on S3. There's those options as well. And Kserve gives you that way to kind of scale your models like you would, if they support it, like you would any other microservice, right? We have ways to, based on demand, scale up your microservice or do canary deployments or A/B deployments. Kserve helps you with all that and much more. Yeah. Knative is a project to kind of enable serverless workflows on Kubeflow. And Kserve, I believe, initially was heavily involved with Knative, but I think now it's no longer a hard dependency. And of course, we've talked about this a little bit, the model registry is a component that's up and coming for Kubeflow, as well as MLMD. Well, it's based on MLMD, which is machine learning metadata, which is a project on Google as well. All right. Let's deploy some stuff with Kubeflow that actually does things. So does anyone have any questions about Kubeflow? The question is there any projects that NVIDIA has? My understanding, and that's a great question. So has NVIDIA integrated deeply with Kubeflow? My understanding is that the MPI operator, that's been heavily contributed by NVIDIA, as well as Kserve. So Kserve, although not necessarily part of the Kubeflow project, Kserve allows you to serve models from the NVIDIA registries. In fact, we're going to do that today, as well as the Triton containers, et cetera. So there's also the NVIDIA plugin for the GPUs that we use. Other than that, that's all I'm aware of, but we can absolutely, I think that especially Andre and the training operator team will be very, very familiar with who's contributing to that. But is there any particular projects you're interested in? Yeah, good question.
I did have a question. It's more on like the side. Has this particular
that would be awesome. So I know the Google Summer of Code, Kubeflow now, I believe it's the second year in a row is being used. So you can go, build components and contribute to Kubeflow. As for hackathons, we haven't had any community hackathons, but that'd be phenomenal. Do you have kind of an idea for what a hackathon would be with Kubeflow?
Just that question.
Yeah.
I could try to look it up, but at the Meta hackathon for Llama several months ago, one of the tables sitting next to us was using Kubeflow to like train a model to do whatever their project was.
Cool.
At the hackathon. So I've seen it in the wild at least one time at a hackathon.
So just in case the mic didn't pick that up, at a hackathon, was it Meta Hackathon?
Yeah.
For Llama, the Kubeflow was found in the wild to train a model.
Yeah, and so that was like $10,000 prize. So
Oh,
I
sweet.
think people were willing to put a little more effort into.
And I know that KubeCon India, that's training Llama. That's training Llama v3. So the question was, can you use Kubeflow for more than just what it seems at first model training and serving? Is there more to Kubeflow? And the answer was that Kubeflow is a really general purpose system, and you can use it for things like data preparation. You can use it for things like data engineering. In fact, Spotify was using a tool called Luigi, and they actually opted into using Kubeflow pipelines because of the flexibility of Kubeflow pipelines in general. And I think that that is a core, the gift and the weakness, especially when getting new members into Kubeflow, is, well, I want a super highly specialized tool. Absolutely, that integrates with Kubeflow, but out of the box, it's really supposed to be general purpose, so you can adopt it to a lot of your workflows within your organization. That was the goal from the get-go. And then empower yourself with Kubernetes to be that kind of data center API and orchestrate all these different tools for you. Does that answer your question? Awesome. I like it. I like the questions. Anyone else? Okay, sweet. So let's get a little hands-on with Kubeflow. So we're gonna just walk through a demo. I can give you access to this repo. If you have your own cluster, you can pull this up. The reason it'd be hard to do with like 25 people is because there's some admins, like from your notebook, there's a few things that you don't have direct access to that I'd have to. An example is, authentication policies. So what's cool about your notebooks is if you know just enough Kubernetes to be dangerous, you can run like a kubectl. Oops. Is it mad at me? Let me reload. You could run like a kubectl git pods. So you could troubleshoot if something went wrong, or kubectl git actually boost jobs. And you can see jobs being launched. The other thing that's nice is there's certain things you can't get, like a cluster role, because it's a cluster-wide resource. So you really can provide an environment based off the service account for specific teams within a specific namespace to restrict access. So you can really give them that lab as a service without worrying about the blast radius of someone being able to edit maybe like a cluster role. So if we walk through this workflow, so we're going to make a RAG application. So RAG applications is retrieval augmented generation. So the idea is I'm going to ingest some documents. These documents happen to be about Kubeflow. They're from the Kubeflow course. We're going to ingest some documents into Professor Cube, which is going to be our chat app. We're going to ask questions. The first response is going to be super slow because we're going to use the CPU. Then we're going to deploy it using NVIDIA NIM, and it's going to be a little bit faster of a container. We're going to use Kserve, and we're going to get a better response. So you're going to be able to see, although we're not going to be training, fine-tuning it, you'll be able to see putting up a little Gradio app and then serving some models with Kserve and then playing around with notebooks.
That's the beta.
Right. Yep. And so I'm hosting all the containers for this demo myself on my Docker Hub, but I provide the manifest if you want to build them yourselves, as well as I comment out in the Docker files, like if you want to edit, if you want to serve it at like a different / location, right? I'm doing it / Professor Cube if you want to do / my fun app or whatever. So so I do have my little app up. And I don't think I have a model behind it. I think it's going to be mad. Yeah, so there's no app yet. There's no model. Let's refresh. So let's go back to our doc. So the first step we would do is I'm just using MinIO. You can create a client, create a bucket. Oops. Make sure everything's installed. Yeah, that's a great question. The question was, what is MinIO? MinIO is its object that you can host on Kubernetes, but it also can be used to abstract APIs between clouds. So although I'm using the MinIO API, this is actually, I believe, writing to Google Cloud Storage. So you can just call call MinIO, and no matter what object you're using, you can choose what to back MinIO by, and it'll just write to that object store. Yeah. So it's actually a microservice running in Kubernetes or Kubeflow right now on Kubernetes called MinIO. So I can list my buckets. I'm gonna just call this in. I'm gonna list the current objects. So I already ingested them to save us a little time. Make sure the bucket exists. So if I were to kick off this upload file, what I would do is I would upload all these files to this bucket. It's just a MinIO client. Yeah. So what we're trying to achieve is I have this chatbot, and I'm going to ask this chatbot questions about Kubeflow, and I had to ingest some documents from the course that we wrote. And so right now there's no model. So are you familiar with Gradio? So Gradio is a really quick way. I believe it's Hugging Face Gradio. It's a really quick way to build just like a front end for a large language model or any application, and it calls Python on the back end. And you can use it with, like, we're going to show you, use it with Kubeflow to make a call to an LLM. Good question. Yeah, good question. So we're going to serve everything with kserve, including the vector database. And when I call Gradio, it's going to actually just call my served model on the back end. So we'll walk through some stuff. We'll walk through a little bit. But so what I would do first is I would ingest all my documents right into object store. And once I'm done ingesting my objects into the object store, I'm going to deploy my vector database. So your vector database is so that when you store your documents, we're going to serve that with kserve as well. When you store your documents, you need something that's going to grab similar documents based on the query. So what it's going to do is it's going to embed the query into a vector. It's going to look at that query and say what other query or what other documents are similar to this query. It's going to pull those documents, and it's going to feed that context to the model. So that's what we're going to do. And that way the model, instead of just arbitrarily responding based on either it's pre-training understanding or maybe going out to the internet, you have curated documentation for it to reference. So once I apply this, so I can apply to create my vector store. And let this run, and then we'll do kubectl get inference services. kubectl apply. Yeah, let's take a look. We are applying these manifests. So this is just the default MinIO secret information. And then I'm deploying this vector store, which is actually like a TileDB headless service that's going to act as your vector store, because a vector is just an array, and it's just easy for me to set up. And then it's going to access MinIO to ingest those documents. Yeah, that's actually living on this container. If you look at that image, I put the service in that container, and then it's going to load the vectors into memory. The other way you could do this, if there's different architectures for vector databases, the other way to do this with TileDB is you could actually load all your vectors as arrays onto S3. And then because of how the engine works with slicing and dicing things, you can only bring what you need from S3 into memory. So it's much more efficient and quicker. So that's one way to do it. There's other vector stores that'll be mainly in memory, right? So they just scale up and keep everything in memory to be as fast as possible, or on disk. So there's those kind of the different models. All right, so they're going to apply the inference services. Okay, so my vector store was already up, but it looks like my vector store is officially up. What's interesting is if we did, you see, to get pods. Where is it? Where's my vector store? Let's look at. Let's describe our inference service. Here's my endpoint. Maybe it should tell me what the pod name is. Here it is. You can see here, I had passed some previous documents to my model, but you can also see it ingesting. It creates a new index and it's actually ingesting those documents. So now that we have the documents ingested and the inference store is happy, we can actually just ask our vector store something. And this is just the vector store trying to get information, right, from the documents. It's finding things that sound similar. It's like not really natural language. It doesn't sound so great. So what we need to do is we need to deploy a custom model and a custom transformer. So the custom transformer is going to, before we get a prediction from the model, the transformer is going to take our query, it's going to embed our query, pass it to the vector store and say, hey, find me something similar to this query, get that context, and then the transformer with the power of K-serve is going to pass that then to large language model. Large language model is going to have that context and generate a response. So we can just apply this. And we'll have to wait for this to be ready. While we're waiting for that to be ready, we can actually this is what our transformer looks like if you want to look at the code. Yeah, so once the model's up, we'll pass a query. The first query we passed was just what is Kubeflow, and we just got a vector response. Now we're going to wait for the model to be up, and we're going to actually pass a prediction to the model and say what is Kubeflow, and it's going to go get that context from the vector database. So we're slowly building it. I showed you part one, and we're going to say, in theory, it would then take that context that it just showed, and it will pass that to the model and say, hey, answer this query using this information. Yeah, if you spun this up yourself, you could absolutely try another prompt. Let's see, this will get ready for us. All right, so it's ready. It's served. I actually believe we can even see our endpoints. We can see our two endpoints that we just created from the Kubeflow dashboard, which is pretty cool. We can now see what models are available. Two different ways, apparently. And then we can send a model a prediction. And we're gonna send it a request here. So here's the prompt. You're an AI assistant. Use the following piece of context, and we're gonna say what is Kubeflow, with apparently 5,000 tokens. How long do you think this is gonna take on a CPU? It's gonna take a while. Not too long. Well, actually, I believe it'll take about 45 seconds. The Gradio will show us as it's loading, so we can all sit here together and feel the weight of CPUs. Yeah, good question. So the first part is, if you look at my vector store, so let's go back to my Docker file. I built a vector DB. Here's my vector DB. Part of my vector DB, when it launches, it connects to MinIO based on the bucket I passed to it, and then built the index, and then it created the vector database. In fact, that's what this is. If you see the logs, I don't know, those are pretty hard to see. But then again, that didn't help. You see how it's downloading the text documents? And here it created a new index. And now if we go over to my transformer, this is the model. So this is going to be when I created my inference service, I deployed a transformer and a predictor. This transformer is going to go access the vector store and say, based off this query, give me the vectors. And then it's going to pass that entire context to the model that's at the predict. Did we get a response? Oh, it's still waiting. 5,000 was maybe too many tokens. We can move on. But we can actually quickly test this with our Gradio. Let's make sure we do like, there, 100 tokens. It'll out, so tokens is how many tokens it will output. So I'm saying, give me a shorter response. You can actually choose the documents to retrieve through here, as well as, how greedy or how creative, right? You can adjust those for your models. That's the temperature, right? And those are the statistical probabilities of the next token. The higher the temperature, it's going to take actually one that's less significant. In theory,
So these are parameters that the user is able to adjust for passing back to the inference part.
yeah, so I'm passing them. So Gradio is going to pass that information onto Kserve. And if we actually go look at Kserve,
Train the model, take the inputs, run through the pipeline, give me an answer.
yeah. So I'm actually deploying the pieces. So actually, what's happening is my transformer and my predictor are actually both just warm, waiting. And Gradio is going to pass that query to my transformer, which is then going to say, before I can ask the model the answer, I need to then give it context. So the transformer's code just goes, okay, here's my query. I'm going to go ask the vector database, which has all my documents in it. And I'll say, hey, vector database, give me the most relevant documents based off this query, right? This is where you hear from like prompt engineering. This is the thing with prompt engineering. It's based on your prompt. It needs to be encoded so the computer can understand it. And then you send it to a vector. And then there's, approximate nearest neighbor. Oh yeah, there's all sorts of different algorithms, or brute force or whatever, to try to find the most relevant documents. And once you find those relevant documents, then based again off the quality of whatever your question was, it then will go past that context to the model. It would be just equivalent as when you're talking to ChatGPT and it's like, give me a plan for the 4th of July and it's wrong. And you're like, okay, well, I want to do fireworks. Like you're giving it all those contexts. That's all really drag is. You're just passing more context to that model. You can, right. So you could absolutely, and this is actually the complication when it comes to tuning a RAG system, is you can output the vectors, but also you can then choose different types of algorithms based on how you built that index, right? Because you need to build an algorithm that the index to create the algorithm to create the index, then algorithm to actually query those vectors. So you can toy with those as well to see, but ultimately it's the quality of the output, which is in and of itself difficult, right? How do you provide a valuable output, and then how do you correct that? And that's where fine tuning comes in. Especially if you're using internal IP where you might have different overloaded terms and you want to fine tune the model to understand, or maybe use multimodal data from your organization. But then again, that like measuring the value of a response is something that I see is really hard, right? And also depending on the cost of a poor response, right? If I'm a coder and I'm coding something, and I'm like, what's the best way to do this Python algorithm? Well, I can check with my compiler immediately, and it either gives me it or it doesn't. if I'm a doctor, right, and it's saying, oh, what's this diagnosis? I might not want to just read the LLM and be like, sounds good, and then go write a prescription. So I think that's kind of, there's different things to tune to try to do that, and RAG can sort of help, but it depends on how you trust and validate that model. Yeah, so if you were going to look at kind of like the ML ops loop for the process that I've set up, the first human in the loop would have been the curation of documents, right? So like if I go to the NIHS and I'm, I learn everything I can about some genomic, maybe infant genomic testing, there's the question of, was it good science, and how do you evaluate that it's good science, and then bring it into my curated documents so that my model can pull from the context. Just like if you had a junior clinician, well, how do I know that? How can I validate that? Well, you need to go read the papers. Well, what's a paper worth reading? So you have to curate the documents. And then once you have the documents curated, that's where the experts are in the loop. And then the experts will enter the loop again when you look at the output of the response, and it was a valuable response. And then the expert might say, this is the response I'd actually expect from this model. And then that's more of a fine tuning process.
This final recommendation.
Yeah. So the question is how transparent or how well can you unpack the training of a neural network? And I'm going to say, even passing in and seeing all the weights and how they're adjusted, et cetera. And what I'm going to say is I am definitely not an expert on deep learning. The only response I've heard to something like that is when it comes to adversarial AI. With adversarial AI, if they think the panda is a given, which is the classic of adversarial AI, the answer is to create a new data set and retrain it because of how much of a black box the neural network can be. So that's my understanding. Now, again, I'm not a data scientist, but that's kind of what I've heard as I've talked to data scientists about training models. And that is one of the deep learning weaknesses, is that they are kind of a black box. Then that went crazy. Are there any data scientists in here that disagree with me?
I hope so.
Okay. Yeah. Perfect. Let's see if we got a response. We got a response, finally. Yay. Now what we're going to do is we're going to quickly clear all outputs. This is the front end. So now we're going to serve Llama. We're going to serve a better model. And we can actually just do this under the hood. I created my secrets, my Docker registry already. I'm to deploy a new runtime, which you can look in a K-serve. It's a K-serve runtime. I'm going to deploy a new inference service, and I'm going to give it actually a persistent volume claim so that I can just pull the model and serve it. And if I need to rebuild, I can just serve the model from my memory or from my disk. I wonder if it actually is happy with this predictor. And in theory, we could actually curl and see if we get a better command or get an answer. What's it mad about? Like that. And we can go look. Let's make sure. I don't think it actually updated my inference service. That's my hypothesis. No such thing as stupid questions. Just curious minds.
How would you like swap out the underlying LLM? You had a base LLM, you said console one, and then you went through this approval process, added relevant documents in this fun, cube space to go, and now you're going to go run it and then swap out the underlying LLM. Does it retain the advantages of the documents? Do you have to go back and retrain it again? Do you have to run through the pipeline again?
Phenomenal question. Great question. So the question was, hey Chase, there was one model, and then you did some magic, and now there's another model. What happened to that other model? And so what happened is because I'm using Kserve and because it's serverless, what I could do is you've got your API endpoint, right? You got Gradio, and Gradio is just looking for like an endpoint, and that endpoint will not change. And so that endpoint is just called LLM, and it doesn't know what microservice lives behind that endpoint. Then what happened is I upgraded the model. I changed the model under the hood. So the Gradio is going, I'm just going to go call LLM. And instead of the original model picking up the phone, it's like a way, like you got like upgraded. Your platinum card hit and you got status. And like now it's like the real people that are going to help you at the airport answered. And so like the new model came in and that's what's happening, but it's still the same number. It will just go, wow, I'm getting a better quality response because I'm just loading that new model at that URL.
Were you asking about the vector DB and the embeddings? Well, I was trying to figure out if the training process, I guess I'm just wondering. Okay, I think I know what you're saying. It's like there was no training here at all, right? Okay, so
Right.
I think what it is just structurally, I think what the issue is, you had the vector DB, right? So you put the documents in the vector DB, yeah, embedded, right? Yeah. You got the map, got your matrices, right? Yeah. But over here, you had the one model that you're gonna take the hits that you got in here, yeah, right, into the query, into when you're doing the inference into this model, right? So what this is doing behind the scenes, you're now just looking at this other model using the same vector DB that got the same data. So the process really doesn't involve training. It's really retrieval augmented. Let me go find relevant.
Right.
Your other shit.
Right.
You're just
right.
It from like Claude and you're putting over here in ChatGPT. Like that's all you're doing. The front end stuff you did.
Exactly. So right. And so fine tuning would be in between the two. Yeah. No, fine tuning would be so you let's just say we just take like a zero shot or like a one shot, like single shot. That means you're just like, tell me about scoliosis, right? In it, outputs, and you just say that's what you get. Now, what happens if you say that I see what you did, model, but this is the response I would want? So what you do is you would take that output and you would actually create a fine-tuning data set. Instead of doing a full retraining of the model, you just do a fine-tuning job that will just tweak how that model understands those outputs and will be more accurate based on your training data set. So instead of fully retraining it, you're just fine-tuning it. Right. Right. So the missing piece of this full end-to-end is that I'm going to, like when I finish this demo, we'll then go fine tune it with Llama and we'll show you how to do that. Right now, what we're showing you is serving kind of a model on a CPU, slow, not good enough, upgrading that model under the hood to use a GPU, use a better model, and then that last step will be fine tuning the model if we still don't like the response. Right.
Model you have here, images here.
I have Llama. Yeah.
7B. No.
7B. Yep. Is this my 5-minute warning? My 2-minute warning? $30 minutes? Oh, that's a long time. I'm almost done.
Oh, that's perfect.
Okay. Oh, okay. No, I don't need 30 more minutes. Once this predictor's up, we're going to ask it a question. And it's going to give us a better response. And we're going to go thumbs up. Thumbs up, and like a 3, 2, 1 break. And we're all going to jump. And there's going to be a picture. Yeah. Yeah.
Explain like the difference between predictor, transformer, like Llama. Include both these pieces, or?
Yeah. So Llama is the predictor. A transformer is typically when you're serving something data and you want to like transform and morph that data in a way that the model can understand. So for us, the transformer, when I first call it, instead of that query going right to Llama, instead of what is Kubeflow, the transformer is intercepting the query and saying, oh, I need to go part of my data processing or my transformation job is to go get the relevant documents from the vector store and then pass it to Llama with that context. So it sits in front of Llama. And in theory, we can give it 1,000 tokens. You think this will take 388 seconds?
It was that LLM URL private DNS?
I believe so. Yeah.
Can't. I was gonna try to look up GPT.
There you go. So that was a way faster output and a way better output because now we're serving it on a GPU node as well as Llama. It's also worth noting, just for those, we can see that it actually scaled up, unless it doesn't let me do this. It actually scaled up a GPU node for us to serve that LLM model. And once I get rid of that LLM that's requesting a GPU, it'll free up that GPU node for us. So, and that is a quick relatively quick RAG demo using Kubeflow and LLMs. Of course, the next step would be fine tuning. And that's your Kubeflow crash course. Awesome. Well, thank you, everyone. You know where to find me and contribute to Kubeflow.